Right, welcome. I think it's time to start now. Maybe it was a bit short, but the next talk will be by Wesen on making simple musical interfaces and instruments. And for those who really liked it, there's going to be a workshop tomorrow at 11. Should you already be up and running at the Congress Center.
Get some coffee and join the workshop tomorrow with some cup of coffee. I've got hardware as well. So.
All right, sounds great. Get loads of coffee. Enjoy.
Hey, thanks. Hello, I'm Wesen, or Manuel, and I'm going to talk about making music and especially programming musical algorithms on special hardware. So I've brought some development boards with me. We're going to be able to use them to show you some stuff. So I'll first start with some kind of intro. If I just, I'm going to talk about algorithmic music mostly. And I've been producing electronic music for the last 3 years probably. I started with just doing some kind of beats on the computer and then moved on to doing mostly music with hardware. I'm playing bass as well, so I'm like kind of touching everything a bit. But my real background is actually in programming and hacking. I've been going to Congress for 10 years and learned electronics on the fly during just a few years, especially because I was interested in building MIDI controllers using microcontrollers. So I think this is a picture of the first controller I built about 3 years ago, which was this really big, clunky box, wooden box, with some potentiometers, some knobs you can turn and then some buttons you can press. And it actually worked quite nice, and I did a few gigs with it, and then it broke, and every week there was like one part that was broken. But the actual insides of the box are pretty much the same than what I'm using now. This one had, who knows about MIDI, about microcontrollers? Sorry, just like, okay. So, and who knows about MIDI and synthesizers? Okay, quite a few more. So, basically a microcontroller is just a small CPU in a chip that often has a lot of input-output hardware, so you can just hook up switches to it and pods. And that's what I've been using in this box, for example. There's one controller which polls the whole devices, like ask which value has this pod and is the button pressed, and a second Atmel doing USB, which is slightly more complicated, but it's one of the main things which led me on to build all this stuff. So that was 3 years ago. I did like 2 gigs with it and noticed it was way too clunky, way too prone to errors and trouble, but it was actually really nice to be able to just program the stuff I was thinking of. And if you buy a finished MIDI controller, you basically have some kind of software to edit it, but once you hit the limitations, you're just stuck and you can't really do what you want with it. So that was the thing I really appreciated about building this device, is just being able to put in the stuff I really needed and have it the way I wanted it to be. From there on, I moved to using the computer for music production, to using special synthesizers and hardware about 1 year ago. And that changed my whole way to do music, actually. On the computer, you can just like pull in some big programs and program some complicated stuff that's going to generate music in some kind of weird ways, but in the end, it doesn't sound really good most of the time. And I've been moving on to mostly this synthesizer I have here, which is just a drum machine, so you can just have sounds like this, make some kind of music out of it. And in the process of doing that, I've been focusing on a lot of more minimal ideas. You just have like 2 bars to make music on this one, and you don't have all the options of doing the stuff on a computer. But since all these ideas are pretty simple, the whole physical feedback takes a much more significant aspect of making music, like being able to turn knobs and explore stuff away from the computer, away from the internet and from chat programs. And it really changed the way I did music, and that's the first few tracks I really liked came out of this. But it also has its limitations. Most of the limitations are you can store 2 megabytes of samples on this one and like 4 gigabytes in RAM on this one. And if there's a feature you want to access and you can't really access it easily, there's no way to get out of it. So for example, on this machine I have an effect called a delay, which just repeats sounds at specific intervals. And to access the parameters for this delay, you have to enter menus and press a lot of buttons. So it's not really something you would like to use live and change the settings on the delay when you're in a club. So, I downloaded the manual for this machine and went out looking for manufacturer-specific messages to change the way the delay is set, and found out that you can actually set the delay settings using a MIDI message which is sent over this cable. And while doing that, I decided to build a new MIDI controller which just had 4 parts and MIDI out just to control the delay. And I did this, and it again completely changed the way I did music, just being able to access some parts of the instrument and turn it into a real new instrument I'm actually really comfortable with playing now. I practiced a lot, and now I like to, I don't know if you listened at the beginning where I was playing a lot with the delay while I was playing. And that got me really excited about the way to actually, hack existing synthesizers to use features which I don't really have just by adding some hardware and then suddenly being able to change a lot more things. So I spent a lot of time then reading internals and doing some MIDI programming and programming on microcontrollers, and found a lot more new ideas to actually use, for example, this drum machine. While doing that, I decided, I noticed like a lot of people were actually interested in using that stuff as well, so I decided to create a company last year. So that's the only company slide. I did a new design of the controller, which allowed to hack around a lot of limitations of the machine run, which is this device and another synthesizer called the mono machine. But I actually noticed you can actually apply that kind of thinking to every software and MIDI hardware which is out there and trying to, make it fit your needs. So, yeah, I've decided with a friend called Ruin, who does analog electronics, to start a company which is actually based around this hacking open source kind of idea. So we put all the schematics online and source code. And that's the company slide. So those are the 2 new controllers I built, which evolved from the idea of this simple controller which you can actually program yourself. And what I did is, that took me a long time to get there, but I finally decided to use the Arduino software environment, which is a software environment which allows you to really easily write programs for microcontrollers and just like write a few lines and upload it and test it out. So you can actually, less than program an application, just write some sketches and try them out and see what it does. And I've been integrating both our controllers into this environment, and since I did that about 10 days ago, I've been writing approximately 20 new firmwares in just 1 week, because I was just like trying out nice ideas. And this is actually what I'm going to talk about in this talk. So that was the introduction to show you where I'm coming from. And we're now getting to where the fun is. And while thinking about all these things, I've been really interested in musical theory and aspects of flow. How does your environment or your instrument influence you when you're doing music? Like, for example, why did I never do some kind of minimal techno while using the computer, but started doing this when I had the hardware? And also some kind of really nice insights which came out of trying different algorithms to work with rhythm, and suddenly start to notice that actually most of African and Western music is kind of based about some core ideas which make some music funky and some other music not so funky. And it's actually numbers. It's actually, for me, it's numbers. And that's what I'm going to talk about as well, which is really what fuels all my hacking of these things. So, yeah, I think it's pretty nice to be a programmer interested in music, or musician interested in programming, because it allows you, to merge hacking ideas and like musical ideas, musical theory you have on one side, and then programming theory on the other side. For example, if you studied classical music and started writing counterpoint, which has a lot of rules as well. You always want to kind of put a mathematical frame on it, and I started to notice that both the creative aspect and the theory aspect of it fuel each other, which is really, really interesting. So I've got some posting on my blog about the links between techno, for example, and African traditional music, which is really something, very simple when you see it, but it's kind of pervasive. So that's what interests me the most in the hacking side of it. But now let's get to some technical details. So MIDI is a pretty old protocol which is used to communicate between hardware machines or computers to exchange musical information. It was actually published in 1983, so 25 years ago. And it's based on a serial link with 30,000 bits per second, so it's really slow. And it has separate wires for receiving and sending. So for example, this is the sending side of the drum machine, and this is the other cable which receives the information, so it's really, you can really see it. There's some kind of electronic information, it's a current loop, so if you want to see the board tomorrow, so there's this chip which does the conversion. So there's a lot of thought that actually went into this protocol, and I think it's kind of interesting that even 25 years later we're still using it mostly for most of that electronic music connection, even though we have USB, and there's some new standard which is based on Ethernet mostly, but we're still using MIDI actually in the studio most of the time. So the MIDI information on the cable is encoded in bytes, but there's one slight trick that the most significant bit of that byte is used as a command flag, so you can do signaling of commands. So all these values from 0 to 127 are data bytes, and the rest is comment bytes. So it's pretty easy to check if you just received a comment or some data byte. On MIDI, you also have MIDI channels, which is another way to multiplex information on this one serial link. So you can have 16 MIDI channels on one cable, basically. So you can connect multiple synthesizers and address them individually. And the MIDI channel is always encoded in the lower nibble of the command byte. So devices can listen on a specific MIDI channel or on all channels. And there's this thing called system messages, which is further split into real-time messages and system exclusive messages, I think they're called, which is used to actually send some kind of system information which is not musical. So those are the commands you have for music. So you can send notes on. That's, for example, when you press a key on a keyboard, it's going to send a note on, and when you release the key, it's going to send a note off. And you can use controller change messages. If you turn the knob, for example, it sends just a value from 0 to 127. Then you can use program changes to, for example, change the sound on a synthesizer or to load a new track, maybe. That's kind of manufacturer specific as well. You have weirder messages like aftertouch, which is used on touch-sensitive instruments or keyboards, so you can press the key and then continue to press it, and it will send the information. But then you have real-time commands, which are called real-time because they have a high priority. So it's clock messages, for example. If you have something which is called a sequencer, which is basically just a program that sends back stored information, it's going to have to be synchronized to, for example, another sequencer, so that they don't start to play out of phase, out of rhythm. So it sends a lot of these clock messages regularly on the MIDI cable, and it's used to synchronize sequencers, for example. You have start and stop messages, and then actually the most interesting kind of message for hacking is system exclusive, which is just, this is a bunch of bytes, do whatever you want with it. And if you remember correctly, it's 8-bit bytes, but the higher bit is used for command signaling. So if you do some sysx messaging, you have to encode the 8 bits data and 7 bits data and then put it back out the same way at the other end. So it's pretty annoying if you just want to write out something and you always have to encode stuff. Sorry? Okay, yeah, there's some way to actually put the length in it, but I think it's just the first byte which is specific, which says, you know, this is the start of a sys6 message, that's the vendor ID, and that's the end of a sys6 message, and what's in between is actually whatever you want. So on the MIDI side, that was what the protocol looks like. When you're programming, you only need to know it if you do like the lowest level of it. And I've provided some libraries to do it, so you don't have to worry about that. But it's still very interesting to know how it looks like. And in a MIDI studio, like an electronic music studio, you usually have 3 kinds of devices. The first kind of device is mostly receiving data, and that's synthesizer. So they just receive, for example, play this note, and the synthesizer will play the note. Then you have devices mostly sending data, which is sequencers, which play back MIDI information, and MIDI controls, which are just used to control other parameters of MIDI devices. And what our hacking is going to concentrate on is mostly on sequencers and MIDI controllers, which is because we can produce sound on it. So yeah, there's different ways to connect MIDI to a computer. If you remember the old sound cards, they all had this joystick port to which you could plug in a MIDI cable. Nowadays, it's mostly FireWire devices and USB MIDI devices. So my devices have USB, and you plug it in, and it appears as a MIDI device over USB, and you can use that to send information or to reprogram it. And the MIDI bus can be changed to serial bus, and on most devices you have one input port, one output port, and a through port, and this one port just electrically mirrors the input port, so you can chain multiple synthesizers and have them all respond on the same data that's sent in. And if you want to do more complicated stuff, which actually is pretty almost always, you have to use custom MIDI hubs and MIDI mergers. If you want to synchronize some device of a friend and you want to send clock to it, then the nightmare starts, and it's like drawing network topologies when you're setting up a network, you know, at a LAN party. The device I built is based on a NatMel microcontroller, and what I did in the last few days is actually integrate it with the Arduino environment. So I don't know how much of you have heard of Arduino. That's nice. So what I basically did is add a menu to Arduino to program the microcontroller over MIDI. So you have one menu where you can select the MIDI device. And I wrote a lot of libraries you can use in Arduino to send MIDI messages, to receive MIDI messages, to synchronize to a clock. Some weird sequencer ideas I also built, and some stuff to parse sysx, to encode sysx. And so a lot of the quite complicated sometimes functionality has been integrated for easy use. Like one of the most difficult things to build was, besides the USB MIDI stack, was to build synchronization, to have a tight synchronization to an external device, or to be able to send clock that is tight. That was quite tricky. And if you want some hairy technical details, you can come to the workshop tomorrow. But mostly, if you just want to try out some easy ideas, you can just fire up Arduino and write a few lines. And most of the examples I'm going to show now are based on this. So it's based on an Atmel CPU, and the libraries I've written in assembler, which is all for the Voodoo time-critical stuff, which is parsing all the knobs and buttons and using the display, and also for MIDI clock. And the rest is written in C and C++. So on the Arduino side, you just have your C++ objects, and it's all pretty easy. So what this really changed for me is, before, I mean, I've been writing firmwares for microcontrollers for a few years, but always when I wanted to try out some stuff, like for example, you could just use that button to do this thing, it will involve making a new directory, copying all my libraries into it, and make a make file and writing a new main function. So it really slowed me down, because I would just say, let's do it tomorrow. And what I can do now is, if I have just an idea, just like press Apple N, write a few lines and upload it, and that really changed the way in the last 2 weeks, I just wrote so much more firmware than I ever did before. And it's much more exploratory. So I don't know if you've been using processing as well. You know the feeling when it's just like easy and it works, and you just try out some stuff. So yeah, I'm really excited about this actually. And the cool thing about it is if once it's written, you just plug it in and it works, and you don't need to set up some software which does some kind of merging, which is going to crash. And also, if you don't want to use a computer to do music, you can actually pull all the algorithms you have in, for example, stuff like Maximus P or so, and just put it into hardware. So Maximus P is some kind of weird signal programming program which you can do some weird stuff with. Yeah, and I tried out a lot of crazy ideas, mostly randomizing parameters, so it's always very nice to have a synthesizer patch and just press random, and yeah, that's nice, it sounds nice, and store it. I built a lot of sequencers and also cool tricks to interface with hardware, like for example, when I wanted to access the delay on my synthesizer. So I'm going to show you a few of those things I built in the last few days. So are there some questions before I move over to the examples? Are there some questions about MIDI or microcontroller programming? None, so I'll move on. Yeah, one of the most obvious features you can do is actually just change the behavior and the layout of your MIDI controller. So if you want to have this note on this knob or this one on this one, you can do it pretty easily. And you can implement custom features for your software or synthesizer. For example, one of the things you can do with the machine drum is, I'm just going to load a patch and show you what I mean, is it's mostly a drum synthesizer, so you mostly have sounds that sounds like this. And what you can do with it is actually pitch the sounds so they sound like notes. So that's, for example, a snare drum. And what I can do is, so the idea was to actually convert a note I play on the keyboard to a pitch message value, which is going to be something like 81 is a C, and 85 is a D, and 87 is an E, and program it into this device and just hook up a keyboard to it and play the drum machine as a synthesizer. So that was actually pretty easy to program, and I'm going to show you an example of that later on. I did the same with a machine called the Mono Machine, where it was lacking a few features I really needed, and a lot of people actually wanted to have, and was able to program them just in a, because it's actually pretty easy code. It's just like, oh, if I receive this byte, I'm just going to send these 2 bytes. And there's no way to do it usually. So another thing I did is the program called Ableton Live. I don't know if you've heard of it. It's one of a program to make and play electronic music on a computer. You can actually load scripts into it and access the internal information of the music that is running. And I use that information, sending it back to a MIDI controller to actually display clip names and display some information, and also to randomize the setup of your music piece. So it was pretty fun as well, and it's always like kind of going into the back door and trying out stuff like you would do in software hacking. So yeah, that's the example I showed. Just use the pitch of percussion machines to play notes on the drum machine. So you can actually use a hi-hat and play it as some kind of bell, or the snare drum, which normally sounds like, sounds kind of like this. So you can change it to have something like this. On the Mono Machine, I had, one of the really cool things about this is that you can randomize sounds in a kind of intelligent manner using genetic algorithms, for example, or using interpolation to discover new sounds you would never come up with by hand. So you, for example, I can store like a parent sound and a mother sound and then merge them and try out some new variations. So it's pretty funny as well. It's what we did all So I'm just going to skip this. One of the controllers I built for the mono machine has a joystick in, and you can control all the sound parameters at once with this one joystick, for example, or randomize just whirling the joystick around. And this was the Ableton Live API, which is written in Python, and I spent a lot of time hacking into it and looking how it works. So if you're interested in that, you can also come tomorrow, and I'll show you the programs. But let's get to some use cases, what it actually looks like and how it feels to use them. So this is the simplest program you can actually write on this one. Is just sending a note if you press a button. So I have a setup function and a loop function, which are not used in this exact example. And the handle GUI function is used to handle all the stuff that's buttons and encoders and stuff. So if the first button is pressed, I'm just going to send out a random note. And that's all you have to write, and then you can upload it on the device connected to a synthesizer and just press random notes. So it's kind of a stupid program, but it's fun in itself. So now the algorithmic stuff starts. For example, I want to take that random pitch and map it to a minor scale. So I've written this tool called ScalePitch, which is just going to take a random note and scale it to a C minor scale. So that already sounds much more interesting, for example. And the program I'm going to show you now, it's called Random Notes Test. And it's the same concept than what I showed before, but this time I'm going to produce some pitch information for the drum machine. So I have this snare drum. I took my frequency analyzer and then input every value for the pitch and just wrote down what kind of frequency it was and then mapped it to notes. And then I built a lookup table to produce the correct pitch for each kind of sound you have. So that's the lookup table for the snare drum. So if you want to play a chromatic scale, it's just those values you have to input, and all the microcontroller is going to do is look up the correct pitch information for a note and send it over to the drum machine. That's the setup function of this sketch, where I just tell the library that a snare drum is loaded on those first 4 tracks here. So that's the snare drums, and I put some delay on it so it sounds cool. Delay and reverb is always the way to make good synthesizer demos. So I just tell the library which kind of sound is loaded on each track. And that's the function now. So I have 4 buttons, and if one of the buttons is pressed, I'm just going to send a note on. And this function in the machine drum library is just going to convert the pitch of the note into a pitch for the machine drum. So what it sounds like, and if it should be working correctly, is if I press the buttons on my board here, it's just going to play some random notes on the snare drum. And then you can start to change the sounds of the machines. So it's actually good fun to just sit in front of the device and go. And it's all just those random minor scale notes, so you can come up with some nice chord melodies or just have fun with it, or record it and then take out some good things. So yeah, with 4 lines of code you have a lot of fun, and you can just unplug the device from the computer and use it later on. So it's pretty nice to go away from the computer into the studio and then just try out the new tools you programmed. I'm now going to go into a bit of mathematics, and a few months ago I discovered this paper by Godfrey Toussaint, which is a musician and mathematic researcher in Canada. And he wrote this really nice paper where he shows that the Euclidean algorithm to find the biggest common divisor between 2 numbers can actually be used to generate most of African and Western rhythms. So the paper is actually about rhythms, but it starts with, I think, timing system and neutron accelerators, which is actually built on the same principle. So it's a good read. And then he goes on later to show where this algorithm is used as well. And the idea is actually pretty simple. You take a pattern of a specific length. So for example, you take a pattern of 8 steps, for example, 16th notes. And you take a number of pulses, k, which is smaller than n, and you distribute these pulses over the pattern so that it's the most regular kind of way. So for example, you could take 3 hits and distribute it over 8 pulses, and it's going to give a pattern which sounds like this. So it sounds like all kind of dancehall music. I'm just going to program it in here, and you'll see what I mean. So it sounds like... so it's some kind of... I'm going to put it on the bass drum, and then you'll start to recognize it. So that's just 3/8, for example. And if you go into more complicated rhythms, for example, distributing 4 pulses over 9, it's going to give you this pattern. And it always sounds like kind of familiar, because even if it's like a 9-step long pattern, which we're not really used to here in Germany, you would be if you lived in Bulgaria, for example. But it sounds really natural because it's almost regular, and then at the end it just has 1 step more. So you can use these mathematically generated patterns to actually program some really kind of nice flowing rhythms, because most of what I discovered is funky, for me at least, is based on this kind of regular distribution. So a lot of the music I do is based on that kind of idea. So it's really cool to have a way to actually try them out just by inputting 2 numbers. And actually, if you read the papers, I think like on 10 pages he goes through every K and N variation and lists all the traditional rhythms, and like this one is used in rock and roll, and this one is used in Cuban music, and this one is in Africa and Nigeria. And it's really interesting to read it and then to look up the ideas. So my idea was to build a sequencer where each track is actually just generated using K, N, and an offset. So you can start at different points in the rhythmic pattern. And the implementation of that algorithm is very easy. In the paper, you have a way to calculate it by hand. But if you actually program it on a computer, the simplest way to distribute these K pulses over N is just to divide N by K and then count it up. So the algorithm itself just looks like this. You have a pattern with 32 bits, for example. For the longest one is 32. And then you just go increment that counter and then set the bit if it just overflows. So that's written in fixed point arithmetics because it's on the microcontroller. But it's really simple. It doesn't need a lot of CPU time, and there's good fun with it. So I built this 4-track synthesizer using the tempo synchronization on my board, so it's really tight when you use an external sequencer. You can generate the tempo internally as well, and then use a knob to set the BPMs, for example. And all I do is on every 16th callback, I'm going to use Euclidean rhythm tracks, check if that track is being hit, and if that's the case, I'm just going to trigger a track on the machine drum. So I haven't actually took the board with that software with me, but if you come tomorrow, I'll be able to show you, and there's some really cool rhythms and polyrhythms hidden in it. Yeah, and it's an amazing way to try out these kind of polyrhythms before trying to work them out by hand. You can focus on a few and try out all kind of variations just by turning the knobs. So it's really nice to get into the flow, and I use that. But one way I extended that idea was to use that algorithm to generate the rhythmic pattern of a bass line. So most bass lines, I think it's easier to think of them as a percussive pattern, which maybe has a few notes in it, but mostly it's just percussion. So what I use is use the Euclidean algorithm to generate the rhythmic pattern of the bass line, and then use an arpeggiator, which is just like a cycle of loops, to put some pitches on it. So if you take a few pitches and play them on every hit, if the length of that pitch pattern is longer than the rhythmic pattern, it's going to swirl around and make some kind of polyrhythm on the pitch level. And it's actually a really nice way to come up with disco bass lines and that kind of stuff. And still using the Euclidean algorithm, the pulse is going to be quite regular. And so if it's slightly off, it's going to sound really syncopated and stuff. So I'm going to demo you that firmware here. So I just have to plug in a few devices. And it's this board here. So the way the sketch works is it's produced on 3 levels. The rhythm information is produced by an Euclidean track, which just generates the rhythmic information, like the one I showed you before. So you just input K and the offset. And the notes are produced randomly, but are stored in a cycle. So you can press a button and come up with some new notes. And then finally, these notes are transformed into the machine drum pitch. And it turns the machine drum into some kind of weird, bassline synthesizer weird thing. So I think I have a pattern here, which is just a bass drum. So just to show you some basic pulse information. And what I'm going to do now on the 16 callback is just have this area here where store the pitches and just loop around that area. So if you know C, this is just a way to increment a circular buffer. And that's the callback function I get from my synchronization stack on every 16th note. So let's try it out and I hope it works. So here the notes. This one is the baseline I'm using to produce the pitch information. So that's the same if you use it on the machine drum, it's going to have all these kind of weird pitches, and it's transformed by the MIDI Arduino. So that's some kind of regular pattern, and I'm just going to randomize the notes on this one. It sounds quite stupid, but if I start to change the pitch, the rhythmic track, for example, just put 3 hits in 8 pulses, it's going to sound like this. Which already sounds way cooler, I think. And then if you start to randomize it using, for example, just 2 notes, it's going to... I can go up to 3 notes. Go over to 4 notes, for example, and then start to go into polyrhythms where the rhythmic track is going to wrap around the bass drum, so it sounds like this, for example. So that's 7 against 8, or 7 against 4 if you want. And you can go into way more complicated stuff. Just start to add the prototypical techno stuff into it, which would sound like this, and have fun with it. So. And just, I don't know, have fun with it. So it's really interesting to come up with these ideas for this. Thank you. So that's really one I've been using a lot yesterday. We made a few tracks with it because it's just really nice to actually, reduce yourself to just 2 notes and then start exploring rhythmic possibilities with that, for example. And as I said, I'm going to show you that later if there's some time left. But another thing I've been doing is I bought a CNC mill not long ago. I've talked about everybody that knows me just knows like CNC milling. I actually bought it to do casings for my MIDI controllers, so to mill them out of aluminum. But I was starting to look into the stuff you can do with the CNC milling application. It's just like a whole crazy world, and there's going to be Breeze talk later on, which is just about that. And one thing I've been doing for Christmas is I've been thinking about doing to mill LED lamps out of wood, so just have some kind of really simple frame and then mill some openings in the side which are going to be generated using algorithms and look really cool, you know, have some kind of phase effects and all the stuff you wouldn't really want to mill by hand, but which a computer you can do really well. So I haven't actually finished those lamps before Christmas, but I'm going to show you the design application I've wrote in processing to just come up with some kind of cool ideas. So I use processing to generate some kind of 3D scene and then convert that 3D scene to DXF and then import it into the milling application. And what I do is control the design parameters with the MIDI controller rather than with the mouse, for example. So if you use the mouse, you would have to, you know, input some kind of control surface and processing. It's all pretty annoying to do. So I just hook up the MIDI controller and say, okay, the first parameter is going to be, you know, the number of circles, and the second one is going to be the width of the circles. And I think oh, there's some, you don't need to see that. I'm just going to open processing and show you the application. Oh, that's Arduino, sorry. They look so similar, I'm always confused. So that's processing, that's the code to generate my lamp. And you can see here I use my library to open the MIDI device and then just get some CCs out of the controller. So I'm going to start that one and hope USB MIDI is not broken today. So that's the kind of ideas I had for the LED lamp, to just have the side of the lamp with these kind of attractor patterns, and you know, there's going to be some pulsing LEDs inside and it's going to look really, really cool. And every side is going to be different with some different attractors, or you can use lines and have some kind of line attraction, which looks really cool as well. And normally if I just use the controller here, I should be able to change the parameter. So it's pretty interesting to just turn knobs here and see how it's going to look. And you know, just press randomize. And I think one of the things I've been doing is hook up a sequencer to that. So it should, you know, I can just. So I think that's like 80 BPM or so, and it's going to change on every 16th note. So you can use it for techno visuals or so. But it's actually really fun to know. You just like try out how is it going to look like this, or maybe I need a lot more, or maybe less. And if you start to go into weird zones, it's going to look like this, which is pretty cool as well, but I don't know, that's a bug or so. But actually the cool thing about it is that you're going to input some parameters you haven't thought of before, and the most important thing is I think you can change 2 parameters at once and just see how it interacts. And if you just have the mouse, you'd have to use some kind of, not a knob, not a slider, but some kind of other input device. So here you can just go and, you know, change it like this. So that's one of the cool things you can use MIDI for as well, is just use it as a GUI for a lot of applications. I think 2 years ago we built a laser controller, you know, with galvanometers and controlling the mirrors. And I was, you know, I don't like GUI programming, I like embedded programming, so the control software for the laser was just the MIDI controller. And you could, you know, change the animations and stuff. And it's much easier than writing a whole GUI, you know, with GUI callbacks and widgets and all kind of weird stuff I don't understand. So let's switch back to Keynote. So yes, that's, I milled circles of different radii, I think, or radiuses, radii, I don't know. Using attractors to create attraction zones, and you can actually apply that kind of thinking to every kind of graphical algorithm. Sorry, radii, okay, so different radii, or you can use lines, or for example, if you take one shape, for example, triangle, and then just start to morph the triangle over the whole design, which is something you'd never be able to mill that precision by hand, but it just looks really cool when it's just like perfectly phasing around the lamp, and then you have an LED inside that goes. Yes, I just use my MIDI library to control the parameters, and here I have this callback on controller change, and you know, there's some kind of weird ideas you can apply to that, which is like tempo synchronization, or you can use it easily to hook up a MIDI controller to control visuals in the club setting. Or what I did in processing was having all these animations synchronized to not MIDI clock, but MIDI notes, and then just program one track of the drum machine to send notes to control the visuals. So I just had to start the laptop, put it on one side, and then do everything on the machine drum. Yes, so that's when I randomize the attractors when receiving a note. So when I press one of those buttons, it just randomizes the attractors. And yeah, it's an incredibly interesting thing to do. I think when you see the amount of musicians that use programs like Maximus P or just write ideas down by hand, because, for example, serial music is just some kind of weird theory to generate music as well, and use that as a foundation. It really changed the way you think about music when you start to think that, you know, you can actually implement those rules and implement the haptic feedback as well using knobs and buttons. So even if knobs and buttons are boring, you know, you can do a lot of stuff by just double-clicking them or holding one button and turning the other, or turning two at the same time with just using a simple joystick. I think there's really a lot of things we haven't really discovered about just using knobs to control software. And yeah, it's pretty hands-on now because you don't need to know much about microcontrollers or flashing or electronics or whatever current and voltage is to try out these MIDI ideas in a hardware setting. I think there's a workshop tomorrow, so I've actually brought 12 or 13 of those boards with me, which have an Atmel Amiga 32 processor and a display and USB. And if you want, you can just join tomorrow. We can try out stuff with hardware synthesizers. I think a few people have brought synthesizers as well. You can, of course, control software synthesizers as well, and processing sketches and all kind of other crazy ideas. And I've got a lot of more patches, which I didn't show just now, which are pretty cool as well. Like, for example, doing some kind of automatic wave slicing on the machine drum, which is pretty cool. So yes, thank you. And if you have any questions. I think there's one question in the first row.
Just with the mic, because otherwise it won't go in the stream. Is it working? Yes, it is.
Does this work with control voltage and gate also, or just MIDI?
At the moment, it's just MIDI. I have one at home, like a MIDI CV converter. So if you actually just hook up a MIDI CV converter to that one, we'll be able to do it now. But I have one version which is, you know, we're building analog modular synthesizers as well, so that's one of the aspects. For those of you who don't know what control voltage is old analog synthesizers don't understand MIDI information, and you actually use voltages to control the pitch and control the different parameters, so you just plug cables with voltages on them into the synthesizer. And that's, of course, one of the things we're really interested in, is also bringing all those ideas to analog synthesizers.
Right, any more questions?
Hi. Sorry, I missed the beginning, so maybe you talked about that in the beginning, but have you, did you have a look at OSC, the Open Sound Control Protocol?
Yeah, of course. That's one of the ideas. OSC is the protocol which I said is based on Ethernet mostly. I think you can send it over everything, but it's mostly used over Ethernet, which is going to replace MIDI sometime in the future. So you have actually a lot of software understanding OSC now. And I think a few hardware boxes understand it as well. So for example, the Monomi controller, which is based on a lot of the same ideas, has OSC, and that's something we're going to integrate. I mean, the thing is, I don't have any OSC device or software, so it's not something I'm really, you know, it's not something I hacked on a Saturday night. So But it's something we're definitely going to integrate, and I think the next controller is going to be a much bigger one to actually handle a UDP stack and an Ethernet stack as well.
Put up your arms if you've got more questions.
None?
Right, right at the, like early on,
Yeah.
I've been asked. Not quite. I've been asked where the talk's going to be tomorrow.
The workshop is going to be in the workshop room, so I think it's downstairs somewhere, and it's going to be at 11, so get your coffee and come there. And I've ported my version of Arduino, which has this MIDI bootloader, to Linux and Windows. So it actually works pretty well on Windows, but on Linux I'm not quite sure what it does. So, you know, if someone knows about MIDI Linux programming, he's welcome to help me. Okay.
Thanks a lot.
Thank you.